more. I'm ready when you are. Okay, so 1/2 x squared for x less than 3, and 2x minus 1 for x greater than or equal to 3. Awesome. I really didn't want a quadratic function in there because we did not discuss 2.5. I know that you know the quadratic function, but I really wanted to discuss it before in 2.5 before we have it on any of these problems, but that's okay. It's fine. Good, so my starting point is here. When I replace this with the interval notation negative infinity 3, the next thing I replace this with 3 to infinity. I will identify the domain next. Can anyone tell us the domain of this function? Everything, very good. Nothing is missing. Negative infinity to infinity. Which x value in this case must be in the table, no matter what? Yes. So don't forget to put 0. And I will use these symbols. Again, you're not hurting my feelings. If you come up with a different method, that's fine. Okay? I will use these symbols right under 3. Exactly how they appear in the intervals. An open parenthesis or a parenthesis to the left and a bracket to the right. Next, I am going to write the functions where they belong. To the left hand side of 3, I will write 1/2 x squared. To the right hand side of 3, I will write 2x minus 1. Yes, it's an overkill. I completely agree with that. However, it saves me time, so I don't have to search which one is the correct one. That's right, they're right here in front of me. But again, I accept any method. So when I plug in 0, I get 0. When I plug in 3, it's ugly. 9/2 right here inside the parenthesis. Let's say I also replace x by -2 because I get a nice number. -2 squared is 4. 4 divided by 2 will be 2. That's enough for the left-hand side. Now for the right-hand side, I have to plug in 3. 3 times 2 is 6 minus 1 is 5, and I write it inside the bracket. And I'm going to choose the next in line 4. 4 times 2 is 8 minus 1 is 7. So I pick some points to the left of 3 and some another point to the right of 3 because this is a linear function. 2 points are good enough. I don't need more. At this point, I start plotting the points. So from left to right, which point is the first that needs to be plotted? Very good indeed. -2, 2, and this is our first point. The next in line from left to right would be? Very good. And the next in line will be 3. And 9 divided by 2 is 4.5. 1, 2, 3, 4, 5. So right here. But this happens to be an open point. How do I know? Because it's a parenthesis. The parenthesis tells me this point is an open point. And yes, this is the quadratic function that we have to graph. And it can be extended only to the left, but not to the right. As you see right here, this function of 1/2 x squared exists only between -infinity and 3. That's it. Between -infinity and 3. And now it has to stop. Then I continue with 3 comma 5. So if this is 4.5, 3 comma 5 is right here. They're not touching. There is a gap of 0.5 between them. And then at 4, this was 5, 6, 7 is this. And this is the graph. Now you can say, you just told us to write the equation or the function. Yes, but for the piecewise defined function, you don't really have to. You can only, if you'd like, you can only just write f of x. That's fine. Because we're not going to graph other functions on the same coordinate system. This is it. So you understand that you cannot extend this line to the left, as you cannot extend this to the right. So every now and then I do see something like this on the test, and I would like you to tell me what's wrong with this. Exactly, it's not a function. Thank you. By the vertical line test, this is not a function. But this one, by the vertical line test, is a function. Any vertical line you draw, it will only hit the graph once. But look here. So please do not overlap those two pieces of a function that is piecewise defined. Good, very good. Next question. Was this okay? Yes, the problem is that my math lab is just asking you check here or click here, and I don't want to say more. Yes, let's do 2b. Okay, in 2b we have the absolute value of 3 minus x over 3 and minus 1 less than or equal to 3. What type of equation is this? I'm sorry, what type of inequality is this? Forgive me. What type?
Absolute value.
It is an absolute value inequality. Thank you. Awesome. How do I solve this? What is the first step? What do I need to do? Correct. Add 1 to both sides. So this is 3 minus x over 3 less than or equal to 4. At this point, do not cross it out like that. I'm just trying to make a point. If I don't know how to convert this into something else, I will not be able to solve. No one can solve this unless he, she knows how to convert it. I don't want you to memorize anything. Remember, this is the idea. I'm looking for numbers whose distance from 0 is 4 or less. Where will these numbers be? So that the distance between them and 0 is 4 or less. Between yes, between -4 and 4. Indeed, they must be between -4 and 4. If the distance from them to 0, the distance between those numbers and 0 has to be 4 or less, they have to be between -4 and 4. Good. So we converted. We are not solving this. We are solving this, which is the same with that. So we convert it into something we can solve, which is a compound inequality. So how do I continue? Suggestions, please. Of course, excellent. Well done. So this is -7 less than or equal to -x thirds, x less than or equal to 1. We subtracted 3 from all three sides. Great job. Now what do I need to get rid of? I need to get rid of -1/3. -1/3. So how do I get rid of -1/3? So this was here, I was subtracting, but here I have to multiply by -3 to get rid of -1/3. So this is x, this is -3, and this is 21. But now I have to think. Well, I'm thinking. What am I thinking about, though? Say it again. I think you said it, but I didn't fully hear it. There is a fan. There is a vent right here. I'm ready. Absolutely, because we divide or multiply by a negative number. Excellent. Thank you. It will not make any sense to say that x is greater than or equal to 21 but less than negative 3. This will be against nature. So indeed, the interval is negative 3 comma 21. I like to write x in. Very good. Excellent. Excellent problem. Next question. Anything else? Let's solve one with the other type. So let's say we have the absolute value of 2x minus 1 greater than or equal to 3. This is not the same type. It's not the same with what we just did. How do we solve this one? What is the idea now? The idea is we don't have to memorize. Please try not to memorize this, because once you understand it, you don't have to memorize it. So now I want these numbers to have the distance between themselves and 0 3 units or more. It cannot be between negative 3 and 3. 3 units or more. So then what do I write? I cannot change the inequality symbol into equals. Greater to the right of 3 or 2x minus 1, exactly what I said. Exactly. So it's either in between negative 3 and 3 or outside. By outside, we mean to the right-hand side of 3 or to the left-hand side of negative 3. This type will always have the union symbol in the final solution, always. Ready? So I add 1, so I get 2x greater than or equal to 4, or x greater than or equal to 2. And then I have 2x less than or equal to negative 2, or less than or equal to negative 1. So these are our solutions. And please tell me what to write. Right here in the final solution. In interval notation with the union symbol. Excellent. Thank you very much. That's it. Exactly what this says. Greater than or equal to 2, and this one says less than or equal to negative 1. Very good. Anything else you would like to go back to? Don't forget the difference quotient, the average rate of change. Don't forget equations. Don't forget inequalities. Finish up your homework. It's mandatory. I will pick problems from what we did, and I will pick problems from these problems. And I will pick from my math lab. Everything that you have seen, nothing that I will invent. Okay, we have 15 minutes, 14 minutes left, so let's find something else. Anything. You pick anything, or I will pick. Do I get to pick? You want me to pick? Okay. I will pick from the end of the chapter 1 review. I will choose some topics and you say this one, this one, this one, this one. Are we okay with equations of any type? Any type of equations that you would like to go back to? Anyone in particular? Another absolute value inequalities? Another quadratic in form? Okay, excellent. So quadratic in form, so here it is. I'm looking at problems on page 212. So here's 196. 3 x to 4/3 minus 5 x to 2/3 plus 2 equals 0. So that's one. And then I would like to look at a word problem on the next page. Okay, ready? Okay, what type of equation is it? And you could say it's also a equation with fractional exponents. I would have to agree if you say that. But we don't really have a tool or a way of solving it, solving this equation as a equation with fractional exponents. So we have to notice that there is some sort of relationship between this power and this power. So what will you say with about the one with the smallest power? Let's denote it by y. As long as this can be denoted by, otherwise the method is not applicable. What will I denote that by? Y squared. So, but is it true? If I square x to 2/3, do I really get x to 4/3? Let's say we don't know, so I'm going to do this. X to 2/3, if I square that, I copy the base. What happens with the exponents? No, it's when I multiply, I add them, but when I take to a power, I multiply. 2/3 times 2/1 is 4/3. So therefore, this is indeed y squared. So the next step would be to write 3y squared minus 5y plus 2 equals 0. Quadratic equation. We have 4 methods. Which 2 methods I would not even think of? Right, the square root is not applicable. Complete the square, I would not. Definitely not, unless you force me, and you really have to force me. So then we either go through the long procedure of factoring, or we use the quadratic formula right away. Because this will take a little bit more than 30 seconds to factor. So let's review the quadratic formula with this problem. So then I have y equals negative b plus or minus b squared minus 4 times a times c, which is 6, over 2 times a. I would recommend putting this in the graphing calculator. It's always easier for you than with this software. So left parenthesis, negative, no, 5 plus the square root in parentheses, you know me, some calculators don't need that anymore. 25 minus 24, close the parenthesis, outside, close the parenthesis, and divide everything by 6. And then copy everything and do it again by simply replacing or overriding plus into a minus. Right here. So this is 2/3, right? You can always go back to math and change it into a fraction. Hopefully it's considering it as a full number. So we got two solutions. One is y equals 1, and the other one y equals 2/3. 1 and y equals 2/3. But this is not what we are interested in. Y was a tool that allowed us to solve this equation quickly, but we cannot leave the answer in y. So this becomes a new equation, and this becomes a new equation. The first equation is what? Very good. X to 2/3 equals 1. And the other one is x to 2/3. Look at that. Equals 2/3. No connection. The power has nothing to do with that number on the other side. Okay. Now, these are two new equations, and these are equations with fractional exponents. Equations with fractional or rational powers or exponents. How do I solve x to 2/3 equals 1? Anyone remembers the technique I suggested? It's up to you. You can use any technique you like. Say it again. We eliminate what first from the power? Which one we eliminate first, the 2 or the 3? Yes, that's the wise thing to do, and so you don't have to memorize any formulas. So then you have x squared equals 1. What happens next? Which method applies here for quadratic equations? Yes, that's the easiest one. So you get plus or minus 1. Do not forget about plus or minus. And we'll have to go back and check. Now we have the other option. In a moment, we'll go back and check. The other option is x to 2/3 equals 2/3. Again, the same thing first. We eliminate the denominator, so we get x squared equals 4/9. Yes, the same procedure, and we get plus or minus 2/3. I don't know if these work. We'll see in a moment. Here's what I recommend. Allow me to show you how to put this in the graphing calculator and check all 4 solutions in a blink. So let's go back. In y equals, we will put in the original function, 3x power, in parentheses, 4 divided by 3. I didn't put divided. I put something else in there. Okay. Minus, I think it was, yes, minus 5x power, in parentheses, 2 divided by 3. Close the parenthesis, and then plus 2. And now we go to second and table. I have to do that all the time because it goes back to the default. And go to second and table, and I'm going to plug in 1, and I'm going to plug in -1. I'm going to plug in 2/3. No, it wasn't. Yes, it was 2/3. Yes, 2/3, and then -2/3. So when I go back and check this number is not 0. It could be the tolerance of the calculator. I still have to probably do it by hand to convince myself that this is okay. But if this is correct, I didn't get the chance to check on my own. But if this is correct, then only the first two, the plus or minus 1, are solutions. The plus or minus 2/3 are not. Unless I entered something incorrectly, so that's also possible. But I don't see any problem here. It's negative 2/3 and positive 2/3. Okay, so I can't vouch for that. I have to do it by hand and check with positive 2/3. So I need to convince myself they don't work. So obviously these, yes, according to what we have, these no, but I have to convince myself. So 3, and then I have 2/3 raised to 4/3, and minus 5, 2/3 raised to 2/3, and plus 2, and see if this is 0. I just want to do this one more time by hand. It's very possible. I'm not saying it's the calculator, but I just don't trust it. So in parentheses, 2/3. And that is raised to 4/3. I just have to do it one more time. Okay, minus 5. And then in parentheses, 2/3. And that raised to, and the power is 2/3. And then plus 2. Okay, the answer is not 0. So positive at, I'm sorry, forgive me. Sorry. Okay, so I did it again in a different way just to make sure. The answer is not 0. Negative 0.06855 is not 0, so the positive and negative 2/3 do not work. I wanted to at least, let's just get one more problem started. The length of a rectangular carpet is 4 feet greater than twice its width. Rectangular carpet. Say it again. Any questions? Thank you. Sorry. Okay, so this is problem 41 on 214. So it says the length of a rectangular carpet is 4 feet greater than twice its width. If the width is x, what can you tell me about the length? It says 4 feet greater than twice the width. 4 feet greater than twice the width. And then if the area is 48 square feet, find the dimensions. What would you just give me the equation? I let you go. I'll take attendance also. So please tell me how you will write this equation.
2x plus 4 times x.
Very good. So 2x plus 4 equals 48, or 2x squared plus 4x minus 48 equals 0. Always keep in mind, simplify. And this should not give you any trouble. Always simplify.